Hello, pre-calculus students, and welcome to the lesson on areas under curves. And as a caveat, we've already talked about how to find areas under curve and estimate them, and this lesson is really just an application of it. Okay, so we'll start with these three application problems. Number one, a car travels at a constant velocity of 65 miles per hour for 3 hours. How far does it travel? All right. So let's calculate this. You got 3 hours, and it travels at 65 miles per hour. Hours cancel, and you end up with 195 miles that it traveled. And it traveled this far in 3 hours. And this is number one. Fairly simple problem. Number two, how far did it travel between 1.5 and 2.75 hours? Between 1.5 and 2.75 hours. So the time elapsed, in other words, how much time went by, is 2.75 minus 1.5, which is 1.25 hours. And we do the same thing that we did in number one. 1.25 hours times 65 miles per hour. Okay, hours should go away. And 1.25 times 65 is 81.25 miles. So hopefully these two problems are just review for you from what you've previously learned, probably in Algebra 1 or maybe even in pre-algebra. Okay? And what we want to do today is really looking at number 3. Give an algebraic and geometry interpretation of your answers in number 1 and 2. So one of the main concepts here in calculus, and I have to remind you, this is a calculus lesson that we're doing here. So one of the main ideas or techniques in calculus that we have to know is how do we make a connection between the algebraic and the geometric. Well, let's see. Let's draw a graph here since we're looking at a geometric interpretation. And our graph is going to have time here on the horizontal axis, 1, 2, 3. Okay. Our units here is going to be in hours. And then this over here is going to be the velocity in miles per hour. And this car is going constant. It's going at a constant velocity. So it never changes, and it's going this far. This is 65. And keep in mind, this graph here is velocity. This here, sorry, the y coordinate, the y-axis here represents velocity, and the horizontal x-axis here represents time. So in our first problem in number 1, what we really did was we took 3 times 65. 3 times 65. So we essentially found the area underneath the graph. So this is the algebraic interpretation. The geometric interpretation here well, it is that the area between the velocity function, and the x-axis equals the distance traveled. The area between the velocity function and the x-axis is the distance traveled. So let me show you. This is the velocity function, f of t equals 65. It never changes. Okay? And this is the time. And remember, if we find this area, which is 3 times 65, that gives us the exact same number as we found up here. And let's look at the other scenario. Let's look at this for number 2. Well, the graph stays the same. I'm going to redraw this graph, even though it may seem a little bit tedious. And this is time in hours. And this right here is 65. This is velocity. Well, for number 2, we wanted the area between, we wanted the time, or the distance traveled between 2.75, so that's approximately here, and 1.5, so that's approximately here. And we essentially found the area of that, okay? Because this distance here, area of the rectangle, is base times height. Well, the base here is 2.75 minus 1.5, so that's 1.25, and the height is, of course, 65. So it's the same thing. It gives us 81.25. It's the same thing. So hopefully from this video, you are able to capture this fundamental idea that if you have a velocity or some sort of rate for a function and you want to find distance, you multiply time and velocity. You multiply time and velocity, which is the same thing as finding the area underneath the curve. Okay, so this is a big idea here, that the area between the velocity function and the x-axis is the distance traveled in the given time. I should say this, in the given time interval. And with this process in mind, we're going to go on to more complicated examples, such as this one, where now the graph isn't so simple anymore. It is a curve. But we will get to that in the next video. Hopefully you are able to understand the main idea here in this part video relating the geometric to the algebraic. Thank you for watching. Have a wonderful day.